Artificial intelligence is entering almost every organization, but not always through the security team's front door. An employee can copy source code, customer information, credentials, or confidential documents into an external AI service without realizing that this creates a security boundary problem. This hidden and unmanaged use of artificial intelligence is commonly called shadow AI. Shadow AI does not require a sophisticated hacker because ordinary business workflows can create it. Developers may use AI coding assistants, marketing teams may use AI writers, and analysts may upload business documents for automated analysis. The risk becomes serious when users move sensitive information into AI systems that have not been reviewed, approved, or monitored by security teams. Shadow AI creates several security risks, and the most dangerous ones involve data leakage, credentials, vulnerable code, privacy, and loss of visibility. First, sensitive information can leave the organization, while credentials accidentally pasted into prompts can become exposed to an external service. Second, AI-generated code may introduce insecure patterns, while uncontrolled data processing can create privacy and regulatory problems. Let's visualize what happens when a developer sends confidential source code to an unmanaged AI service. The developer believes the request is harmless, but the organization has no approved control between the laptop and the external AI service. Once sensitive material crosses the approved security boundary, security teams may have limited ability to determine what was shared, where it went, or how it was handled. Shadow AI is not only about employees leaking information because attackers can also target AI-powered applications directly. An AI application may have access to internal documents, APIs, databases, or business workflows, making the AI layer a valuable target. Attackers can abuse techniques such as prompt injection to manipulate an AI application into revealing information or performing unintended actions. This means organizations must secure both the way employees use AI and the AI applications that connect to enterprise systems. Another shadow AI risk appears when developers trust generated code without performing normal security review and testing. For example, an AI assistant may generate code that looks correct while still containing an injection vulnerability or another unsafe design choice. The correct approach is to treat AI-generated code as untrusted output and apply code review, testing, scanning, and secure development practices. The answer is not necessarily to block every AI service because organizations need a practical way to enable useful AI while controlling risk. Start with identity controls, data loss prevention, application security, logging, and centralized monitoring so security teams can see and control AI usage. Organizations should also maintain an approved AI inventory that identifies which tools are allowed, what data they can process, and who owns each service. Finally, security awareness is essential because technology controls cannot fully compensate for employees who do not understand what information is safe to share. A mature shadow AI program combines policy, technology, monitoring, and user education into one continuous security process. The key controls include an AI usage policy, strong identity, data protection, continuous monitoring, an approved AI inventory, secure development, and employee training. Shadow AI is not simply an AI problem, it is a visibility, data protection, identity, application security, and governance problem. The goal is not to stop innovation, but to make AI adoption visible, governed, monitored, and secure. If you are building an enterprise AI security program, start by discovering shadow AI usage, classifying the data involved, and applying controls based on risk. That is how security teams can turn shadow AI from an invisible risk into a governed and manageable part of the modern enterprise.